is.
Okay. All right, so atomic radius. Radius is the distance between the center of a circle to the outermost point, okay? And so in terms of an atom, we're talking about the distance between the nucleus and your outermost valence electron. So you should remember that the trend for atomic radius is that the radius gets bigger as you go down the periodic table and bigger as you go to the left on the periodic table, okay? So let's use two elements as an example to help us figure out who has a bigger atomic radius, who has a smaller one, and then why. So if you take a look at the periodic table, you will notice that lithium is right here, and then sodium is right there. So following the trends, you should recognize that lithium is the smaller one and sodium is the bigger one, okay? Now, we need to be able to answer why. Why is this happening? So if you take a look, lithium has 2 energy levels containing electrons, whereas sodium actually has 3 levels. 1, 2, 3, 4, 5, 8. Okay, so this one should be pretty intuitive to you. Which one looks like it has a bigger radius? The answer should be sodium. Okay, so as you go down the periodic table, the number of energy levels, or shells, increases. The more energy levels, the greater the distance, which means there's a greater radius. Okay, so that's how you would do this going up and down the periodic table. Now let's look left and right. Okay, so again, if you were to look at the periodic table, you would notice that lithium is right here, whereas beryllium is right here. So who should have the bigger radius? That would be lithium. The smaller one would be beryllium. But again, you need to be able to answer why. So these guys are in the same energy level, which means they're going to have the same number of rings as each other. Okay, 2 rings. But the difference between these two is that lithium has 3 protons and beryllium has 4 protons. And if you remember back to Coulomb's law, we know that the more charge you have, the more attraction you have, kind of like a magnet. Okay, the stronger the magnet, the stronger the attraction. Okay, so that means beryllium must have a stronger attraction between its protons and its valence electron. Okay, so from left to right, the number of protons increases. Which means the attraction increases. And because there's a stronger attraction, the electrons are going to get pulled physically closer to the nucleus. So they're being pulled literally closer to the nucleus, towards the nucleus. That is why atomic radius gets smaller as we go left to right, because the more protons we have, the stronger the attraction pulls the electrons towards the nucleus. Okay, we're good.